So in this video we're going to talk about Kubernetes pods. So we're going to cover that why do we need pods, because we already have containers. So what is the need of adding another layer or another concept which is known as pods? After we understand why do we need pods, we'll talk about pods in a bit detail, which is pods introduction. And then we'll cover what is the difference between container, right, when the container is deployed by itself versus when a container lives inside a pod, right, when it's deployed inside a pod. Then we will talk about pods with multiple containers, that what are the advantages and disadvantages and all, and what scenarios should you be using multiple containers in a pod. And then we'll be doing an exercise where we'll be creating and deleting the pods. And last we'll be covering that how can we manage pods using labels. So let's get started. So assume you have four components in the application. One is the backend server, other is frontend, and next you have a database and a cache. Now in order to be able to deploy it, you need to first package it. So for packaging you use Docker and then you containerize it. And now when you're deploying it to a server, since Docker processes or container processes runs in an isolated manner, you can straight away talk to the container. In order to be able to talk to the container, you have to map the container's port to the host port, right? And then you can talk to the host, to that port on the host, which means you're talking to the container now. So that's what we have done here. So we had just container images, and now when we're running into a server, so let's assume this is a node or server, or it could be a VM which has an IP now, and you're mapping like four containers and you're mapping ports of these. So port 8080 of the backend server is mapped to port 8080 of the host, and for frontend you are mapping 443, and for the database you do it for 5432 to 5432 on the host, and similarly you do it for the cache. This works fine when you just have like one container of each type of application or each type of a component. But suppose you get a lot of traffic for the APIs and you have to replicate the backend server. Now to be able to run multiple backends, you can straight away map 8080 to 8080 port, right? Because the next port, like, so when you have the next replica coming, it needs a different port, right? Because 8080 is already occupied with one of the processes that is running. So you do the mapping. So you map the first backend instance to 8080, the second to 8081 on the host, and the third to 8082. Now this looks fine when it's just 3 replicas, but assuming you have 20 containers and for each container you're running like 4 or 5 replicas, so which creates a lot of complexities. So you have to deal with hundreds of ports and you have to see which ones are free and which ones are busy. So this adds a lot of complexity. So Kubernetes simplifies this process and also few other things by introducing pods. So let's see what pods are. If you see now, there is a new layer around all of these containers. So this new layer is pod, and now each of these pods has a different IP address. So the mappings for each container remains the same. So you're mapping container 1 to IP address 10.1.1.1, and you're mapping port 8080 to the 8080 of that pod, right? So since the mapping of the container to of the container port to the port on the pod remains the same for all 3 replicas, it is very easy for us to create new replicas, right? Because we are not managing any ports and all. Like in the previous example, we had to change what port is mapped on the host machine. Since now every pod has a different IP address, the mappings are very simple, so it is very easy for us to create new replicas. So this introduction can be derived from the diagram. As we saw there, pods represent the basic building block in Kubernetes. A pod is like a host because it has an IP address and a range of ports, and we map the port of the container to port on the pod. Other important thing to notice that IP address of a pod is reachable from all other pods in a Kubernetes cluster. So if you see this diagram, like the networking layer is a flat structure, any of the pods could call other pod. So a pod could contain one or more co-located containers. So just like in a container, we just mostly run like one process. Similarly, in pods, we mostly try to run just one container. If you're liking the video so far, please hit the like button and subscribe to my channel because it motivates me a lot. So let's try to create a simple backend server and a container out of it, and also a pod. So suppose we're creating a server which takes HTTP requests and responds to it. So we deploy it on port 8080, and we use Node.js. So we add a switch statement, which is basically sees what's the URL, and based on the URL, if it is node app, we will respond something. Otherwise, the default will add like a status 404, and if it matches node app, we would just set like so we'll just say that it's hello world, and we'll ping the host name. So let's try to deploy, first containerize it and then deploy it to Kubernetes. So let's build the server using Docker file. So we just say that how it needs to be built, and at the end it needs to say npm start, which will start the server. So it has built, and now let's push it. So the name of the image is Kubernetes tutorial -002 pods. So we see the image pushed to Docker repository, and let's create a deployment descriptor for Kubernetes. So API version is v1, kind is pod, because we're creating a pod in Kubernetes. We declare metadata. You can ignore the label and all. So we define the specification for the pod now. So the pod has following containers. So containers is a list, and the first one, the name, we say that the container name is node app, and we define that this is the image that we want to use, right? So let's create the pod by executing the kubectl command. So I'll just rename this to pod just for more clarity, and let's execute the kubectl command, which is kubectl apply -f when we just give the file name, and let's say get all to see what all we have. So we see this new pod, right? Node app pod, this is the one which we said, and the age is 6 seconds. So the pod is running now. So this is how easy it is to create a pod. So one of the things that we talked in diagrams was that it is very easy to create replicas. So we can all, like, this is another kind of Kubernetes object, which is deployment. So where we declare what type of containers we want to deploy. So this is the container, and we can mention that how many replicas you want. So to increase or decrease the number of replicas, all you have to change is just the number. So there is no additional port mappings and all that you have to do. So we have seen that how do we create pods and all. So let's try to understand in what scenarios would we have multiple containers in a pod. And normally most of the scenarios we would just want one container to be running in a pod, because it is easy to stop and like kill and restart the pod and all. But there are only certain scenarios in which we would want multiple containers. So some of the scenarios could be like, suppose there is another container that is just there for doing the backups and all, or it is an authentication gateway, like means you're calling some other third-party API, and you want to go through, you want to have a proxy which does the authentication and all. So you want to go through that other container which is responsible for doing the authentication and all. Or it could be something like collecting and pushing the logs. So only in these types of scenarios where you have the second container which is depend upon the first one, right? So you don't need the container which is collecting and pushing the logs if the first container dies, right? Similarly, you don't need the authentication gateway if the container that is doing the main work dies, because nobody would be using the authentication gateway. Only in these types of scenarios you want to put all the containers or both containers in a single pod, so that they all have a same life cycle. But there's some, we have to be aware of the disadvantages that are associated with putting multiple containers in a pod, right? So when you're putting multiple containers, you have to manage the processes yourself. Like Kubernetes provides a lot of support for restarting the pods and all if they are killed, but in case you're running multiple processes and if the main process dies, right, like the pod will still be up, it is not killed, so Kubernetes doesn't come to know, so you have to manage that by yourself. Next is, if all of the processes, right, all of the containers, they're writing to standard output, it is difficult to separate the logs, and it is also difficult to replicate the containers. So suppose if you add, like, if for some unnecessary reasons you add like 3 or 4 containers within a single pod and you just want to replicate one of the containers, right, so it is not possible to do that easily. But if you have that in separate pods, you just increase the replication factor, as we saw previously, of the pod whichever you want to deploy. One of the points to note is when a container is deployed individually versus when it is deployed within a pod, it behaves in a different way because Kubernetes configures Docker in a certain way. So by default, the Docker containers, they have their separate namespaces. So a backend server is not able to talk to a backend container is not able to talk to the cache container until unless cache container maps the port to the host machine, right? After the mapping is done, only then the backend server can talk to the cache container. But when they're deployed within a pod, they share the same network namespace. So Kubernetes configures Docker so that the containers within the same pod share the same network namespace. Now the backend server can straightaway use localhost 6379, which is the port, and talk to the cache. The cache container doesn't need to specifically map the port in order for the other container to access it, right? Again, to reiterate, they're using the same network namespace now. So next topic is labels. So Kubernetes provides a functionality of labels which makes it very easy to select certain pods or to be able to see or list the pods and all. So we have a label here which has that the label app is equal to node app. So we can list specific pods. So we say kubectl get pods po and list saying that which has app as node app. So we see our pod running. But suppose we want to run something else, like we say UI, right? So it says no resources found. So it is very, once we add labels and all, so it becomes very easy for us to debug and see how things and all are going within the Kubernetes. Also, Kubernetes uses labels for other type of resources for any selection strategies and all. So here, like we saw a deployment, right? So in the deployment, we use a selector. We say like it should match the labels. So only the pods that match these labels should have these replica sets and all, right? So, and also we add the labels here. So yeah, so the labels help us in organizing our pods within Kubernetes. So in the video we have understood like why do we have pods, right? What pods are, how do we create and delete the pods and all. So in what cases do we need to have multiple containers within a pod, what are disadvantages, and how a container when it lives by itself versus when it lives in a pod, what are differences. And next we saw that how can we manage pod with labels. So I would be covering another video where I would be covering like the networking concepts with like how they behave in a container versus when a container is in a pod. So those will be covered in detail in the next video. And if you're liking the video so far, please give me a thumbs up and please subscribe to my channel. Thank you.